All right, as we review for your QuadFun test on Thursday, just make sure that you're writing down whatever I write down so that way you can get credit for having all of your work. So zeros. Zeros is a vocab word. In fact, we have several that all mean the same thing. Math rocks. R stands for roots. The O means zeros. And the X is X-Intercepts. They all mean the same thing. So the roots or the zeros are here at 0 and at 1, 2, 3, 4. 0 and 4.
4 minutes to get to your destination. Thank you.
Does this function have a max or a min? So looking at this, the vertex is located at the very top. And when it's the top, that means it's a max point. All right, this one, the print was really small, so I wrote it out for you over here. What are the zeros? This is another vocab word. We've got the math, rocks, roots, zeros, X-intercepts. So the X-intercepts are at -3 and at +1. So C. Make sure that you are selecting all of the possible correct answers, okay? If you had just put -3, you would have gotten it wrong. It's -3 and +1. All right, given this function, find f of -1. That -1 is inside the parentheses, so it's the x value. They're telling us that x equals -1. You can do this by hand by replacing the x with -1. So you would take 2 parentheses -1 squared plus 5 parentheses -1 minus 17. -1 squared is +1. Times 2 gives you 2. 5 times -1 is a -5, and then minus 17. So 2 minus 5 is -3, and -3 minus 17 is a -20. Now, if you're doing it in your calculator, you would plug this into y equals, and we're going to type in 2x squared plus 5x minus 17, and you're going to where the x value is -1. So when the x is -1, the y value is -20. Which of the following is closest to the time when the height is 30? So we're going to go on to the height of 30, and it's hitting it twice, right here at 1 and right here at 1.5. So 1 is an answer choice. I don't see 1.5 anywhere. So I'm going to select the 1 second. So make sure on your test, though, we realize that it's happening at 1 second and at 1.5 seconds. It could be happening at more than one spot. All right, which function shows the parent function being shifted to have a vertex of -5, -6? You can pull the vertex out of these because it's vertex form. Just like with point slope, if it's in the parentheses, so I had over. In the parentheses is the opposite. So instead of -5, this is a +5. And the y value is 6. Is that what I wanted? Nope. Inside is opposite. So this is a +6, +5. Nope. Opposite. So it's -5, -6. Yes, that is what I wanted. This would be a -6, -5. Now, maybe you forget the rule when it comes time for the test. You can plug them into y equals. So parentheses x, let's start over here. X minus 5, close parentheses, squared plus 6. And I'm going to look at my graph. This vertex is positive, positive. I need it to be negative, negative. So that cannot be it. So if I end up typing in the correct one, parentheses, x plus 5 squared minus 6, -5, -6. I could check on my table. -5, -6 needs to be in the middle of the rainbow. So if I'm looking for my rainbow points, we've got -5, -5, -2, -2, and right there in the middle is that -5, -6. Perfect. Which equation would appear to be shifted 6 units up? Okay, so again, think of that I had over. To make it go up, that's a vertical shift. So that means it needs to be out inside the parentheses. So we're affecting this outside part, and it's exactly what you would think. So to make it go up 6, you add 6 right over here. So negative 2 plus 6 is a positive 4, so it would be D. And you could check. If I plug the original, which is x squared minus 2, and then what I think is the answer, x squared plus 4, look at the graph. There's the original, there's the new one. I'm going up 1, 2, 3, 4, 5, 6. Perfect. All right, match the description to its equation. Which one moves right 7? Okay, so right, that's a horizontal shift. So we're talking about this IHOD part. Horizontal, left to right. Okay, so I know it needs to be inside the parentheses. So it's not going to be A, it's not going to be C. And then it's the opposite of what you think. So to go right, it's going to be minus 7. So the answer is D. If you're checking yourself on the calculator, compared to the parent function, y equals x squared, I think that x minus 7 squared will make it go right 7. So let's see. There's my original. And yes, that one did go to the right. Perfect. Range. Remember, what's the doctor's name? Dr. XY, so range is talking Y values. And we've also got robot. Range means bottom to top. So the bottom of this graph, I don't know where it's at, so we don't put anything here. And then the top of this graph is at 3. So all of my y values are going to be less than or equal to 3. All real numbers greater than or equal to 3? Nope. All real numbers? No, it doesn't go all the way to the top. All real numbers less than or equal to 2? Nope. All real numbers less than or equal to 3? Yes. The quadratic equation that can produce this table is, anytime they're giving you a table and asking for an equation, you can put them in stat. So I'm going to click Stat, Edit. I'm going to type in my points. Negative 2, negative 1, 0, 1, 2. Negative 12, 0, 4, 0, negative 12. And then I click Stat, Right. Instead of 4, since we're not in linear anymore, we're going to click 5. And it's y equals, the first number is negative 4. So that's what goes next to the x squared. The second number is 0, which means there's no x. So we just go straight to 4. Now, if you look here for 0, it matches up with a positive 4. So you knew right away that it wasn't going to be B and it wasn't going to be C because these both have negative 4. So because that y-intercept was 4, you knew that it couldn't be C and it couldn't be B. And then also, if you wanted to get really particular about it, these numbers are going down from here. So you know that your graph is going to be going down. And to make it be going down, it's got to have a negative out front. All right, you're trying to throw a ball over a wire that is 40 feet above the ground. The height of the ball is modeled by this equation. What statement best describes the situation? All right, so here's our graph. The ball was initially dropped from a height of 35. Well, no, it wasn't dropped. It's here and you're throwing it, which it even says here. The height of the ball increases until it reaches about 35. Is it increasing until it reaches about 35? That could be it. Time depends on the height. No, time doesn't depend on anything. The ball was in the air for 5 seconds. Nope, it's hitting the ground at 3 seconds. So it's got to be that C. All right, what equation best models the function shown? Okay, again, this is a reflected graph, so you know that it has to lead with a negative. So this does not have a leading negative. This does not have a leading negative. That does have a negative in front of the 16, and that does as well. So it's going to be one of those. And you can plug these in your calculator. So let's see, 140 minus 16x squared. If I look at the graph, all I see is something over here on this side, and then it's hitting at about 3 seconds. That is not what is happening here. Let's see for this one. Negative 16x squared plus 96x. Looks really steep right there, and then it's hitting at 1, 2, 3, 4, 5, 6. Ah, that's about right. If I wanted to look at my table to confirm, the highest point should be at 3, and I can't see exactly where it is. Look, here's some pairs, pairs, pairs. The highest point is at 3, 144. Yep, that looks about right. Perfect. All right, members of the Math Club launch a model rocket from the ground level with an initial velocity of 96 feet per second. What does the point 580, what does that point represent? The ball was dropped 80 feet in 5 seconds. No. The height of the ball was 5 feet. No, that's the 5 seconds. The ball was in the air for 5 seconds. No, the ball was in the air for 6 seconds. It hits the ground right here. The ball returned to a height of 80 feet after 5 seconds. After 5 seconds, yes, it's going up and then it's returning to 80. It was also at 80 over here at 1 second. So this is correct. What is the y-intercept? That's where it crosses the y-axis, so it's right here at 0, 2. What is the range? So according to the doctor's name is XY. We're talking about Y values. So it's not C, it's not D. And let's plug this equation into our calculator. Negative x squared plus 2x minus 9. And if I'm looking at the Y values, pairs, 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 and right there in the middle of that vertex is negative 8. Yep, that's about right. Now, are all of these numbers less than or equal to negative 8, or are they greater than or equal to negative 8? They're more negative, which means they are less than or equal to negative 8. A section of a quadratic function is shown. Which of the following points is also part of the function? So I'm going to look for some pretty points. So here's a pretty point. That means this is a pretty point. Here's a pretty point. So there's going to be a pretty point over here, which that's at negative 2. Your axis of symmetry cuts it in half. So right here cuts it in half. So this is 1, 2. So 1, 2. So that's a point. This is 1, 2, 3. So 1, 2, 3. So a point is at negative 4, negative 2. Now you could also just guesstimate. Okay, if you continue this on to see where something's going to be, negative 4, 0, that could work. That's pretty close. Negative 5, negative 4, no, not even close. Negative 3, negative 2, that's not even close either. All right, the table to the right shows some points for a quadratic function. Okay, so the table is actually below, yes, we know. What is the value of x when f of x equals 5? So that means it's a y value. When does it equal 5? Right here and right here. You need to check all of your answer choices. If I just saw, ooh, at negative 2 and circled that, I'd get it wrong. It's at negative 2 and at positive 2. All right, which of the following is not true? Not true about that graph. So I'm going to plug that in my calculator. Negative parentheses x plus 4 squared plus 6. So the y-intercept is 0, 6. According to my table, the y-intercept is at 0, negative 10. So this one is not true. The graph opens downward. We know that that's true because there's a negative out front, so that's going to reflect it. The graph has a maximum point, so we already know that it's got a maximum, at negative 4, 6. This is vertex form. You pull out the x value, negative 4, the y value, 6. That's true. The axis of symmetry which is the x value of the vertex, that's true too. So that's the only one we couldn't tell without using a calculator, and we know all of these are true based off our equation, so it has to be A. Which equation has a vertex of 2, 7? Okay, so the vertex is 2, 7. This is vertex form. It's got to have the 2, 7. This has 4, 19, so it's not either of these. But it also has to go through this point. So you could either plug in the 4 and see which of those gives you 19, or we can use our calculator. So 2 parentheses x minus 2 squared plus 7. So this does have, see, in the middle of my rainbow is 2, 7, but this has 4, 15 as a point, so it's not that one. Let's check. So in this one, this is the same, except it's got a leading 3. So in the middle of my rainbow is 2, 7, and yes, that does have 4, 19 as a point. If I was to do it by hand, 3 instead of x, we're putting 4. 4 minus 2 is 2, and 2 squared is 4, so 3 times 4 plus 7. 3 times 4 is 12, plus 7 equals 19. So yes, that does work. All right, the graph of this function is transformed to create the graph of g of x equals 5f of x. What would happen to the new graph? Okay, this is not plus or minus anything. It's not shifting. Okay, this is either a stretch or a compress. So it's not C and it's not D. And this is a stretch because the number is larger than 1. So what we're doing is we're taking it and we're vertically stretching, which is going to make it skinnier. The larger the number, the skinnier it is. And you could test it out with the parent function, y equals x squared. And then what we're doing is we're taking the function but putting a 5 in front. So we're going to take 5x squared. So if that's your original, and that's your new one, it did. It got skinnier. Roots. Again, that's a vocab word. Math rocks. Roots, zeros, x-intercepts. So where are the x-intercepts? There's one at -2, and then a little bit past 3. So -2 and 2. Nope. It's got to be -2 and 1.3. How is the graph shifted from this equation? So guys, from this equation, you should know how to pull out the vertex. The x value of the vertex is a +2. The y value is a -5. 2, -5. So from this equation, it shifted 1, 2, 3 up. Now, maybe you forget how to pull out your vertex. You could plug this in y equals 1/2 parentheses x minus 2 squared minus 5. And if I look at the graph, I can see that the vertex is somewhere over here. Let's find the specific point on the table. We need some twins. -3, -3, -4.5, -4.5. In the middle of the rainbow is 2, -5. That is your vertex. So there's my vertex. And then that's what we need to look at when we're comparing how it shifted. And so it's going 1, 2, 3, up 3. All right, so make sure you have this done. There is some more review that you can do tonight as you prepare for your test.